So I want to take a look here today. We're going to be talking about something called ions. Ions happen when an atom gains or loses electrons. So far, we've been talking about neutral atoms, atoms that do not have a charge. They have the same number of electrons as they do protons. Well, now we're going to say that the atom can gain or lose electrons. Remember, they're around the outside in the cloud. They're very tiny and they are easy to exchange. So this little comic here says, I'm hit, I've lost an electron. And this person says, or this atom says, are you sure? And he says, I'm positive. That's because when electrons are gained, we get a negative ion. And when electrons are lost, you get a positive ion. Electrons have a negative charge, so this would make sense. The more negatively charged things you get a negative ion. When you lose things that are negatively charged, it becomes more positive. You will be able to determine the number of protons and electrons on an ion if you know the charge. So here's an example. Let's look at sodium. So we're going to go to our periodic table here. I'm going to find sodium. There's sodium. Sodium has an atomic number of 11. That means that it has 11 protons today, tomorrow, next week. Except this sodium is not neutral sodium. This is the ion sodium with a +1 charge. The +1 means that it has lost one electron. So that means that instead of having 11 electrons, like it would if it was neutral, it lost one electron. So it has a +1 charge. Here's another example, sulfur. Find this on my periodic table over here. Sulfur has an atomic number of 16, and that means that it has 16 protons. But in this case, sulfur has a -2 charge. That means that sulfur has gained 2 electrons. And when it gains 2 electrons, it's going to be 16 plus 2. So it's going to end up with 8 electrons. Now, these are not specific to isotopes. But if it were, the entire symbol would have to look something like this. You would have to say that sulfur has a +2 charge, and maybe we'd be talking about the sulfur 32 isotope. So this then would give you the information you need to figure out the number of neutrons. With just this, we can't figure out the number of neutrons. Let's look at aluminum here. Aluminum is right here. Number 13 on the periodic table, and that tells me that aluminum has 13 protons. It wants to know how many electrons it has. The +3 right here means that it has lost 3 electrons, so it would have had 13 electrons, but it lost 3, so aluminum with a +3 charge only has 10 electrons. Okay, I want to talk to you about another thing on the periodic table. If we continue to look at aluminum here, you can see that aluminum has a mass on the periodic table of 26.98. And I explained to you that that 26.98 was not the same as saying that you have an aluminum isotope. And even if it was an aluminum ion isotope, you would have a number up here, and this number might be 26, it might be 27, and then this would be your atomic number down there. This would be your nuclear symbol, a full nuclear symbol with a charge in it. The question becomes, where does this number come from, and why doesn't it say 26.98? And let me try to explain that to you. They came up with a system to measure the mass of atoms. Carbon-12, which is a very common isotope of carbon, has a mass of 1.992 times 10 to the -23rd grams. Well, that's not very handy. So instead, they came up with what's called the atomic mass unit, and they actually used carbon to derive this. And that's not very important, because what's important to you to remember is that a proton weighs about 1 AMU. A neutron weighs about 1 AMU, and an electron weighs about 0 AMUs. Now, I put the big numbers there so you could see the entire thing, but we know with sig figs, a lot of times this doesn't really matter, and that's kind of handy for us because this is where we get the fact that carbon 12 has a mass of 12. There are 6 neutrons and 6 protons, and then the electrons, there are 6 of them, but they have a mass of 0. So then what is this number on the periodic table? Why does it say 12.01? The reason it says 12.01 instead of just 12 is because this number is the average of all of the isotopes of carbon on planet Earth, or at least their best guess at it at the moment. So you can see here, as far as carbon is concerned, carbon usually has a mass of 12 or is usually carbon 12, but occasionally we do get carbon 14. And those are the nuclear symbols for carbon 12 and carbon 14. This weighted average is a little bit tricky. It just tells me that there's more carbon 12 than there is carbon 14 or carbon 13. It cannot be substituted for a mass number. It's what is on the periodic table. Now, today we talked about ions. Carbon doesn't usually form an ion, but if it did, we could complete this story here. We could say that we have carbon, and carbon has a -4 charge, and that would tell me that carbon has 6 protons and 6 neutrons because of that carbon 12. And in this case, it's got a -4 charge, which means it gained 4 electrons, so it has 10 electrons. Again, it's